order before. That's unusual.
I know, it's weird.
Huh. Okay. So how are you doing?
I'm actually pretty good.
Okay.
Can you go to the same website we were on last time?
Can you copy and paste it into this chat window? Because I don't have a record.
Yeah. Let's see here. Oh. I'm actually... Mom, can you please be quiet?
My dog came running.
Okay, so... Whoa, this is a lot to copy-paste.
Just double-click it, and it highlights.
Now, where am I supposed to put this?
Put it into the...
Oh, in the chat box?
Yeah, where it says type message here, and then hit enter, and it'll go into the chat box. There you go.
There we go.
Now I can click on it. What's the username?
GR1.
GR1, and the password?
2076. And then we're actually in 7.1.2. So on chapter 7.
Okay.
And you,
exponential function.
I wanted to go down to, so yeah, 724 right there.
Okay.
So I don't have it filled out, nor do I have the equation.
Okay. Now let's look at it here. Well, if y equals a b to the x, and we know that when x is equal to 0, y is 1.2. So I can write this. Right?
Yeah.
What is b to the 0th power?
Just 0.
No, it's 1. Any number to the 0th power is 1. And I mean 5 to the 0th power is 1, 1 million to the 0th power is 1, and even more remarkable, 0 to the 0th power is 1. Okay?
Okay. So
we now know what a is. Since b to the 0th power is 1, we know a is 1.2, which tells us that y is equal to 1.2 b to the x. So this is the equation that we're dealing with. Now,
okay.
Copy and complete each table on your paper and find the corresponding equation. So we still have to figure out what b is and what y would be when x is equal to 3. In other words, I don't know what, if I plug in 3 for x right now, well, I don't know what b is yet. So that wouldn't do any good. I would not be able to come up with a value for y. So let's plug in another convenient point for x and see if we can figure out what b is. Well, when x is equal to 1, y is 3.96. So I can say 3.96 is y, and x is equal to 1. Now I have one equation and one unknown, b. I know what b to the 1 power is. It's just b. So b is equal to 3.96 divided by 1.2. Do you have your calculator?
I do.
What is b equal to?
0.96 divided by 1.2. 3.3.
3.3?
Yeah.
Okay, so now I have my exact equation. 1.2 times 3.3 raised to the x. Notice that my final equation has a y in it and an x in it.
Right.
In other words, we have solved for the a and the b. So this is the specific equation for this table. So now I can figure out what y is going to be when x is equal to 3. On your calculator, do that.
$43.12. It's actually 1244, but I just did 0.12.
Okay, does it tell us anything about how many decimal places we should put? No, it doesn't. So I'll leave that up to you. Although this one used 3 decimal places. This used 2, this used 1. I don't know. I don't know what your teacher wants there. So, okay.
I'll just put the whole thing.
All right. I would use 4, since it seems to be going up by 1 as you go down by 1. So, okay, so that is the y value when x is equal to 3. Now tell me what the y value is when x equals 4. What's the general formula of it?
Is it, wait a minute, when x equals 4?
Uh-huh.
It's 1.2 times 3.3 to the 4th.
Okay, what's that number? Whatever that number is, it's what goes in that spot right there.
Oh, 142.31052.
Okay? All right, so now we have the plan on how to do each of these. In other words, each of, or A and B are the same. We're going to find the exact equation for this model right here. We're going to do it by the way I did it, which is to start with known values. In other words, we start with the general equation, y equals ab to the x. So how do I solve for a? In other words, I need to solve for a and I need to solve for b. And that will give me a specific equation for this model.
You can put 5 in for y, and then I don't know what you would do besides a, b, and then
well, what would go in for x?
X to the 0.
X is
0.
what? Okay, 0. There you go. What is
0.
b? What is b to the 0th power equal?
1.
So
One.
a equals 5. So now I know this.
Oh.
So now I know y equals 5, b to the x, but I still don't know b. So now I use the other data point that they've given us, 2 and 180. And that's going to let me figure out what b is. So what do I want to write?
Using the 2?
Using that and this data point. 2 for x and 180 for y.
180 equals 5 b, no, 5, yeah, 5, no, 5b to the second.
Exactly. Now solve that equation, and I'll have a and b.
Oh, okay.
The first thing I need to do.
You need to get, like, b alone.
Exactly.
No.
Yes. That's the goal, is to isolate b. So
Okay.
what do I do as my first step?
I don't know, other than divide by 180, but that doesn't sound right.
No, not divide by 180, divide by 5. That gets rid of this 5. That gets me closer. Okay, that's 36 over there. B squared there. Okay, I still don't have B isolated. What do I have to do to isolate B now?
Divide by 36.
No. Take the square root of both sides. B equals 6.
Oh.
In other words, what I did, whenever you have an equation where the variable is squared, take the square root of it. Well, the square root of b squared is b. Square root of 36 is 6.
Okay.
So now I have b and I have a. So I know my exact equation. Y equals 5 times 6 to the x power. That's my specific equation for this table, for that set of numbers.
Okay.
Notice that it all depends on the set of numbers you have. I have a different equation for this table up here. Okay, so how am I going to complete this table? What goes right there? What number?
5 times 6 to the first power.
Okay, what is that number?
That's 30 to the first, so it's just 30.
Exactly. So that's what goes there, is 30. What goes here?
30 times 3. Or, yeah.
No. You got to do it a step at a time, because the 6 is being exponentiated, but the 5 is not. So you can't multiply 5 times 6 before as your first action. Remember PEMDAS. You have to do exponentials first. In other words, when you plug in x of 3, you have to take 6 to the third power before you multiply it by 5.
Okay.
So that's equal to 5 times 216, which is 1,080, which is what goes right there. How do we get...
How did you get the 216?
I took 6 to the third power. I substituted 3 for x. Do it on your calculator. 6 to the third power is 216.
Okay.
And then 5 times 216 is 1,080. So when x equals 3, y equals 1,080. How about when x equals 4?
Whoa. That's a big number.
Well, I know, but how are we going to figure it out? I don't care if it's a big number or not. What's it equal to?
6 raised to the power of 4. I did that first.
Okay.
So,
And then multiply it by 5, and that's your answer.
Yeah, 6480.
Okay. So
Okay.
that's what would go in that spot right there.
Okay.
Okay.
And then the other thing that I wanted to work on was 7-29.
Is R equal minus 0.45 a good correlation or a bad correlation?
I don't know. I think it's a bad one.
You're right. That is a perfect one. R equals 1.
Okay.
Okay? So this is really a bad one. So what that means is that all of our data points are all over the place. Now, I can put a straight line through that. If you like, if you said put the best straight line you could possibly fit through that selection of points, maybe I'd put that. But there's a lot of distance between all of those data points and my straight line, which correlates to a low value of R. If I had a high value of R, all my data points would be very close together. So that when I draw my straight line through that set of data points, there's not a whole lot of distance. If I add up all those distances, I get a very low number. So this would be like an R of 0.95. An R of 1 would be where every single data point was on the straight line. So an R of minus 0.45 just means that there's a lot of scatter in that thing.
Okay.
Now what happens if we click on that?
It brings you to help, and then it should give you something like a hint, and then the answer, or just a hint.
Do you care if I look just to see what they have done? Does it affect your
No,
grade?
it's fine.
Does it affect your grade or anything?
No.
Let's see what their hint is. Look at the math notes box in lesson 6.2 to refresh your memory about correlation coefficients. Well, that's not particularly helpful, is it? What does a negative R value mean? Well, that's a good question. I don't know. I know that a high R value means a tight fit. A low R value means a bad fit. I'm not sure what a negative R value means. I don't do a lot of statistics. The one math course that I don't really tutor is probability and statistics. Now, most of the other math courses get a very small sprinkling of those two subjects, and I know a little bit about them, but I don't know a lot. So if you wanted to help, if you were taking probability and statistics and you wanted a tutor, I would not be your person. But any other math, I'm fine with.
Okay. And then, so I guess that one really can't answer.
What's that?
But I said I guess that one can't really be answered then, huh?
Well,
The 7-29.
it can if you want to go look it up. In other words, go to your lesson 6.2.4 and it'll tell you. I don't have that, so I can't look it up.
Okay. And then 7-38, which you won't see until 7.1.3, which is the next lesson.
Okay.
Because like the one thing that I'm struggling with right now is we're learning like how to interpret like percentages of something, and I can't do that.
Okay. Well, this is exponentials.
Okay.
Okay.
Maybe we'll cover the other one another night or something.
There's 3 formulas that are key when you're dealing with exponentials. There is the amount of money you have at the end of a period of time. If you have annual compounding, the formula is the amount you start with times 1 plus the interest rate you earn, all to the number of years you have it compounded. Okay? So if Dusty won $125,000, he decides to place the money into an account earning 6.25 interest compounded annually. This is the equation that fits compounded annually. Because there's also a different equation for compounded more often than annually, and there's a different equation for compounded continuously. You have 3 different equations. So that's the first thing to understand, that this is the equation for compounding annually.
Is that a T or a positive?
It's a T, meaning time in years. Write an expression that represents how much money Dusty will have in T years. Well, the amount he will have in T years is equal to his starting amount. He's going to invest the whole thing. And he's going to get 6.25% interest. Well, what should R be?
6.25?
No, it has to be a decimal. We can't use percent in equations. Whenever you have a percent in an equation, it has to be converted to a decimal. To convert percent to decimal is about the easiest thing you'll ever do. You move the thing 2 spots, the decimal point. To convert decimal to percent, you move it 2 spots in the other direction. Okay?
Okay.
So R is 0.06, not 6.25. And T is an unknown amount. In other words, write an expression that represents how much money Dusty will have in T years. Well, that means my expression should have T as a variable. And this is it. This is how much he'll have in T years. In other words, in 2 years, I could figure out how much he'll have. In 10 years, I could figure out how much he'll have.
And that's our expression?
That's the expression.
Okay.
The bottom one. This one here. This is the general form of the equation. This is the specific form of the equation for this model. How much money will be in the account when he retires in 23 years? So what do I need to write? If I want to evaluate this thing after 23 years, what do I write?
125,000 times 1 plus 0.0625, and then would T T be the 23?
Uh-huh. T is the time in years. So now you need to put that number into your calculator, do the exponential first, take 1.0625 to the 23rd power, and then multiply it by 125,000. What do you get?
Wait, and then multiply it by what?
By the coefficient.
I don't know what that is.
125,000.
Oh, okay. I just got the same thing.
Well, do this first. What is 1.0625 raised to the 23rd power?
4.032418426.
Now multiply that number by 125,000.
Okay, wait. Four point 0.0324 times 125,000. Oh, 129,050.
That's your answer. That's how much you'll have at the end of 23 years.
Whoa.
Pretty good. Turns 125,000 and it's almost $500,000 at a relatively small interest rate. But 23 years he has to go without spending it. So, all right, we got 2 minutes. Is there a 2-minute problem on here?
Yeah. 740B. So I simplified the second part of the negative 2x and stuff, and I did negative 2x minus 4, and then I plugged in what the y equaled, so I did 5x plus 3, and then equals 10. So it's
Now what?
negative 2x. I think it's negative 2x minus 20 minus 12.
Minus 20x.
Oh, 20x minus 12 equals 10.
Okay, now simplify.
Is it negative 22x minus 12 equals 10?
And now simplify more. You get
Plus 12.
you get to that stage of an equation, you want to put all your terms with variables on one side, all the terms with numbers on the other.
Oh, x equals negative 1. Right?
Yep.
And that was 2 minutes.
Okay, Grace. I will talk to you next time.
Okay, thank you.
All right, you're welcome. Bye-bye.
Have a good night.
You too.